Assertion and region question. Here assertion is the basic whole system is advocated by Indian standards for fit design, and the reason is basic whole has fundamental deviation is 0. Here are the options. Both A and R are true, individually true, but and R is the correct expression of A. And the option B is both A and R are true, but R is not the correct expression of A. Here C is A is true, but R is false. D is A is false, but R is true. Here coming to the assertion reason, here assertion is basic whole system is advocated by Indian standards for fit design. This assertion is right. And coming to the reason, basic whole has fundamental deviation is 0. This statement also is right, but there is no interconnection between assertion and reason. So R cannot be a explanation for assertion. So that here both A and R are true, but R is not the correct expression of A. So here the right option is B. Tool life of 10 hours is obtained when cutting with a single point tool at 63 meter per minute. If Taylor's constant is 257.35, tool life on doubling the velocity will be, options are 5 hours, 25.7 minutes, 38.3 minutes, and D is unchanged. Here coming to solution, according to the Taylor's principle, the equation is given by Vt power of n is equal to constant, where V is the cutting speed and T is the tool life, and n and C are the constants. Here, for a tool life of 10 hours is obtained when cutting with a single point tool at 63 meter per minute. Here the tool life is 10 hours and at a speed of 63 meter per minute, and the constant is given by 257.35. We'll have to find out the constant n here. So here V is 63 meter per minute, so that here it is in meter per minute, so we'll have to convert 10 hours into minutes, that is 10 into 16, whole power of n is equal, constant is 257.35. On solving this equation we can get here n is equal to 0.22. Now we'll have to find out the tool life on doubling the velocity. Here when the velocity will be doubled, tool life is given by nth root of c by v. Here n is 0.22 and c is 257.35 by 2 times velocity, that is 2 into 63. So which gives a value of 25.69 minutes or 25.7 minutes. So here the right answer is 25.7, and in the option the correct option is B. B is the right answer. Wire of 0.1 mm diameter is drawn from a rod of 15 mm diameter. Dies giving reductions of 20%, 40% and 80% are available. For minimum error in the final size, the number of stages and reductions at each stage respectively would be. Here the options are 3 stages and 80% reduction for all the 3 stages, and option B is 4 stages and 80% reduction for first 3 stages, followed by a finishing stage of 20% reduction, and here the option C is 5 stages and reduction of 80%, 80%, 40% and 40% and 20% in sequence, and option D is 5 stages and reduction of 80%, 80%, 40%, 40%, 40% in the sequence. So just consider all the options. Suppose if you consider option A, 3 stages, 80% reduction for all the 3 stages. Just calculate the final value of the diameter of wire by the 3 reductions of 80%. Suppose let us say from the option A, the final value of diameter is 15 into 0.8 into 0.8 into 0.8. So we have here a value of, so here 80% reduction, that means here we will have to substitute 0.2 into 0.2 into 0.2. We have a value of 0.12. So here the 0.12 is the answer, but here we need 0.1 mm diameter requirement. So here the option A is not correct. So like that, go for B, C and D, whichever gives the nearest value for 0.1 and which is less than the 0.1, that gives the minimum error in the final reduction. So if you calculate like that, the correct answer comes from B. So here B is the right answer. An assembly line for assembling 5 workers are assigned tasks which take time of 10, 8, 6, 9 and 10 minutes respectively. The balance delay for the line is, here the balance delay for the line is given by 10 minus 10 into 10 minus, sorry, here 10 minus 8 into 10 minus x 6 into 10 minus 9 by 10 into 5. So which is equal to a value of 0.16, that means 16%. So here the right answer is 16%, and in the option the correct option is D. D is the right answer. A machine costs 2000 rupees when installed. The cost of repairs increases 40 rupees annually. The scrap value of the machine is 200 rupees. The economic repair of the machine is nearly dash years. Here the economic repair life is given by root of 2 into p minus s by b, where s is the scrap value, p is the initial cost of the machine, and b is the annual increase in cost of repairs. Here all the values are there, just substitute all the values, that is 2000 minus 200 by 40. Here b is the annual increase in cost for repairs, so which is equal to, which gives a value of 9.5, and it is 9.5 years, and the correct option is C. C is the right answer.